Sorry, question number 2.
Oh.
Sorry. Here we go to the question number 2. Why can't be C? C. Which of the following is a suitable SI unit for the C? C is a constant. So C is a constant. So what is C? C is F over RV. F is what? F is Newton.
Force, Newton.
Newton, right? Force is Newton. R is radius, so it's meter. And V is what? Speed. V is speed. Yeah, speed. So meter per second. So what do you get? You get Newton or -2. Meter -2. What? When you bring up. Yeah. So M -2, S +1. Correct. So should be -2, and then C correct. So C cannot be the answer. So what's the answer given?
Then why A? But why A?
Why is A?
SI unit. SI unit.
Yeah, Newton, you tried to kgms -2. kgms.
Oh, okay.
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 You need to know the Newton, Joule, and what it represents in terms of base unit. These three. Then you can solve everything.
Okay.
Any other questions?
37.
27.
37.
Okay, 37.
Yeah.
37 is B, right?
Okay, 37 electric. Okay, so the branches of the circuit have current I1, I2, I3. Which equation is correct?
B.
B. So we go Kirchhoff law. Kirchhoff law. 3 loops are there. I think we go to the big loop. 2 loops.
So the 2 loops are equal.
First, we take this first loop. First loop. What is the total EMF? E equals to first.
I1.
First, you have
I1, R1.
You go for this direction, anti-clockwise. So E equals to I1.
R1.
So the current flow is down. What? I1. So this PD is positive or negative? This PD is
Positive.
because same direction with your direction. I1, R1. And plus the second PD.
I2, R2.
Yeah, so I2, R2. Yeah, this is one equation from the first loop. Now the second loop.
I1, R1.
We take the big one, the big. Okay, we take the big loop. Okay, then so E equals to how many PD are there? 1, 2, 3.
3.
So this one will be what? I1, R1, right? Positive because it's got current going down. Your direction also going down because we are still going anti-clockwise. And here, I3, R3,
Yeah.
Then I3,
I3, R4.
R4, yeah. Okay.
Oh, so just minus off both, you get 0.
Oh, okay.
Yeah, both get 0. Yeah, correct.
Thanks, Joe.
Okay.
How about 33?
33, yeah. Okay.
Actually, it's C.
33,
33 is what?
C.
How?
33. Okay, let me. Okay, 33. Metal electrical conductor has a resistance of 5.6 kilo ohm, potential given 9 volt. Separate across its ends. How many electron pass point in the conductor in 1 minute? So how many electrons? How many E? So current, we have to find the current first. Current is, find the current, V over.
1.6.
Oh, wait, I got it already. Never mind.
Yeah, correct. Then you use what? I equals to Q over
QT.
OT, but the Q you have to transform to NE. NE
Yeah.
T. You're looking for what? You're looking for the N, the
Number
number
of electrons.
E is the elementary charge.
Yeah, okay.
I can get the answer. Okay. Any other question?
34.
32.
30.
34.
Okay, we go to the smallest number first. Always the same rule.
Fine.
32, smallest number, always the winner.
Have you mentioned?
Okay.
You
32.
play CS by your own. Bye bye.
Bye-bye.
32 donkey.
32 donkey. What
Yeah.
is the velocity of each charge carrier? The electric current in the wire may be calculated using I.
V is drift velocity.
V is the velocity of each charge carrier. To be more accurate, should be the
Drift velocity.
drift velocity. Yeah, average velocity. Drift velocity is the best answer. N is the number of charge carrier per unit volume. Yeah, you have to be careful with this. N is charge carrier per unit volume. What is the unit for N will be? Per meter cube. Unit.
Mhm.
So NA is the number of charge carrier per unit length of the wire. Oh, correct, right?
Is it correct?
N is per meter cube. And A is what? A is meter squared, right? So meter
Yeah.
squared.
That's right.
We get per meter. So the number of
Q
carriers
is charge.
per unit length, yeah.
Yeah, yeah.
Q is the charge of each charge carrier, correct? C. Yeah. D, could be D. D is the velocity of each carrier. In reality, all carrier has the different range of velocity. They don't have the same velocity. The Boltzmann, the distribution, all particles will have a range of velocity. You learn in chemistry, range of velocity at any temperature. Okay, any temperature. So any temperature. Sorry, theta. So you can't say just velocity. You have to say mean velocity or drift velocity. You can't say velocity. So technically D is like not that accurate. So D. Okay. Any other question?
34.
Oh yeah, 34. Okay.
Why is 11 not 6?
Why 11 and not 6? You got 6. Okay. The EMF is 12 volt. Internal resistance is 6 ohms. 3 is resistance. Each resistance 6 ohms. No internal resistance. Okay. What is the power dissipated at resistor R? So they want the power here. So power is equals to, I think too many ways. Maybe you can use I squared R. Okay. I squared R. You find the R first. Or you can go V squared or R. I think for me, I use this one. I use V squared R. What is the voltage here? If you know the voltage here,
12.
yeah, 12.
Voltage 12.
No.
You see, voltage here 12.
No,
Voltage is 12 times 6 over 9.
Yeah. See, 12 volt has been used by this one and also these components, right? These two shares the voltage. This is your V1, this is your V2, right? So V1 plus V2, it should be 12 volt.
12.
Correct. So V2 is 6 ohm resistor. V1 used by how many ohm resistor?
3.
Is 3 ohm.
Combined is 3.
Combined 3. So 3 uses V1, 6 uses V2. So how much voltage of 6 ohm? So total resistance of the circuit, how much?
8.
9 ohm, right?
8 and 4.
9 ohm, right?
Yeah,
So total resistance 9 ohm uses how many volt? 12 volts.
12.
So 6 ohm uses how many volt?
8.
So use ratio, so 6 over 9 times 12. So what do you get? You get 8. So it's 8 volt. So put the 8 volt here. So you get the power. So 8 squared. 8 squared over, 6. Terrible. So 8 squared divided by 6. So you get your answer. How much you get?
11.
So you get
11. 10.666.
so you got 11 C. So C is answer. It makes sense. So I think you go V squared over R. You want to use I squared over R?
Okay.
I squared R is okay. Okay. Any other question?
Question 38.
Question 38.
Nobody like electricity.
Electricity. Okay, 38. 38 potential divider. The electric potential at bottom wire is 0 volt. 0 volt, okay. The current in the component Y is negligible. Oh, the current in the component Y negligible. What is the electric potential at junction X? Okay, another one thing. What do you understand if they say current at component Y is negligible means? It has a infinite resistance or zero resistance?
0.
The component Y has a zero resistance or infinite resistance?
0.
Because the current
Oh, infinite.
Oh,
resistance.
infinite, because it's
Infinite
too big.
resistance.
Yeah.
The current doesn't flow inside.
Good. So it's an infinite resistance. So the R here is infinite. So because R here infinite is same like your voltmeter. Your voltmeter also theoretically has a infinite resistance. If you have infinite resistance here means infinite plus the 50 ohm is 2 because connected in parallel. The effective resistance is going to be how much? 50 ohm and 50 kilo ohm and infinite resistance. 1 over 50 plus 1 over infinite. Reciprocal, what do you get? You'll get back
0.
it 1 over 50 plus
50,000.
1 over infinite, right? Actually 1 over infinite, but
0.
1 over infinite is like 0. Actually exactly same as 1 over 50 lah. Reciprocal. So your R, effective R is what?
50,000.
50,000. So the component Y is never change the effective resistance at the bottom. So it's still 50. 50 here, 10 here. Okay, then they're asking what is the voltage at X. Voltage at X. Voltage at X is same as voltage used by the 50 kilo ohm or 10 kilo ohm.
10 kilo.
50. 50.
Oh, 50, sorry, yeah, 50.
50 kilo ohm. Vx is actually the voltage used by going to be used by the 50 kilo ohm.
50 kilo.
So use the ratio.
Oh, I know why already.
This is V.
5.
So 60 kilo ohm uses
Answer is the
6 volt. So 50 how much? So it's going to be 5 ohm. 5. So confusion is the infinite resistance. It doesn't change the effective resistance of the circuit. Like a voltmeter connect parallel never change the resistance of the circuit. Okay. Any other questions?
36.
36.
Yes. It's about electricity again.
Okay, 36. A cell of internal resistance is 0.5 kilo ohm connected to a fixed resistor of 10 ohm. The resistance of the resistor is changed to 20 ohm. The fixed resistor resistance 10 ohm. The resistance of the resistor is changed to 20 ohm. Which statement is correct? Also, you have the cell with the internal resistance. The external resistance was increased. The 10 become 20. So what will happen? The current in the circuit will aft. It's going to be aft. I don't think so. It's going to be aft because current is what? V over
Constant.
V over R, right?
Yeah.
V is in this case the EMF. R is the total resistance. The first case was how much? Oh my god. Okay, other lessons do they use Zoom?
Yeah, I got
So is it
40 minutes or so.
40 minutes also?
Yeah.
I think
You can change to another apps if you want.
which app?
Use this first. I'll show you that later.
Okay. So 10 plus what? 10 plus. 10.5, huh? Okay. So you get the first I. Second I is 20.5, right? And down is 20.
Mm,
Right? So I don't think so. It's exactly half. Can be
yeah.
yeah, correct. The universal cell will remain the constant, of course. No one can change the EMF. Two things fixed for the battery: EMF and what? Two things fixed for the battery: EMF and
Internal resistance.
yes, the internal resistance. That two is fixed. So correct. B is correct. What? Not correct. C. Yeah, A is wrong lah. Not correct.
Yeah.
Okay. The power dissipated by the fixed resistor will decrease. Fixed resistor will increase. Fixed resistance. Fixed resistance. Fixed resistance will take big voltage. If you take big
Yeah.
voltage, it will dissipate no power. It will dissipate no power. The power dissipated by the fixed resistor will decrease. Oh, sorry, it will decrease. 10 to 20, right? The power dissipated by the fixed resistor will decrease. Power will decrease. What's the answer given?
A.
Hey,
Answer given is A.
yes.
The 10 ohm change to 20 ohm, the current will drop. Current will drop a lot. Okay, current drops. Resistance here get big. So we are not sure power getting big or small, right? P is P equals to I squared R. Okay. I dropping because resistance is going up, but R is getting big. So what happened to the power? One going up, one go down. So we're not sure what the power going up or going down. If you use P equals to R, P equals P squared R, P goes up, right? P goes up. R also goes up. You also cannot tell, is it power decreasing or increasing? But do I tell you one thing? Power versus external resistance. How the graph looks like? It has a maximum value. When the power become maximum? When the
R
resistance,
equals to R.
and
Equals to the internal resistance.
yes, correct. Resistance, So if we go, as just now was 10 ohm, I don't know, 10 ohm, yeah, and become 20 ohm, I think the power should go down. Power should reduce. Power dissipated by the fixed resistor will decrease. Yes, correct. Will decrease.
Yeah.
So it's not correct. It's correct lah. The terminal PD of the cell will increase. Yes, terminal PD will increase.
Constant.
Terminal PD means what? E equals to IR plus I. Which is your
Plus
PD? Which is your terminal PD? So I
the
can.
big R. Yeah.
This is your terminal PD.
Yeah.
So terminal PD. So when the R increases,
Yeah, it increases also.
R increases, but I is, what happened to I? I is dropping.
Also increase.
I decrease, right? R increase means I decrease. Right?
Yep.
Okay. So very difficult to tell this terminal power PD going up. You can tell this. You can tell this. R changing here. Small r. Small r never change, right? But what happened to the I? What happened to the I when capital R increasing? I is
Fall.
Lower.
right. So what happened to
Yeah.
the potential inside the internal resistance?
Lower.
Getting,
Oh.
so therefore, this must get
Increase.
should increase.
I see.
Terminal PD rises definitely. Conclusion: when your external R get bigger, the terminal PD get bigger. So big R's,
Okay.
these two shares the voltage. Big resistance take big voltage.
Mhm.
So therefore, answer is yeah, A lah. Okay. Any other questions? Hey, class, if it stops, I don't know when it's going to stop in 5 minutes. After this, also we have another 40 minutes later, right?
Uh,
Another lesson.
huh?
You have twice, right? Today.
You still want to have another lesson, sir?
Why cannot? I don't mind.
Yeah, okay.
Can we have 2 lessons.
You wanna? Okay, no.
We have questions to discuss. Your paper 2 somewhat.
So 24.
24, okay, 24. 24. Okay, question 24. Stationary wave. Okay, a long tube filled with water, tap fitted its base as shown. The tuning fork sounded above. Allow the run gradually out of the tube, or the level is dropping down. Okay, the level is dropping down. If the level is dropping down, just want to ask you a question first. The level is dropping down. Is it the frequency change? Frequency change or never change?
Doesn't change.
The frequency does not change. Why you say the frequency does not change? Because use the same tuning fork. The tuning fork has its own frequency. But the frequency does not change. Only the pattern is changing from what? From the fundamental to, I think the first you get a fundamental, then to the following one. Following one happens. Okay. So when this happens first, you get a loud sound. I think we did this in the lab that day.
Yeah.
So frequency does not change. So what do you want? A loud sound is heard in the interval of water runs out of a tube. The change in the water level between louder sound is 32 centimeter. This is the keyword. 32 centimeter equals to how many wavelengths?
Half wavelength.
Correct.
Yeah.
So this is the first between the loud sound. Listen, loud sound.
Mm.
So this is
Half of the wavelength will give you laugh sound.
So near times 2.
wavelength is
So times 2 equals 64.
wavelength is 64 cm. Yeah, so C.
Yeah.
Okay. So frequency does not change when the water level get lower. This experiment can be repeated in another way also. They put a tube again, the same tube. In this case, water level was fixed, but they changed the frequency, use a different tuning fork. Then frequency changing. They use a different tuning fork. Okay, the level is the same. Then frequency is changed. Okay, appearance was fixed. It will be fundamental always normally. Okay, so check which one. If the level going down, frequency is constant. They use the same tuning fork. If the level is constant, they change the tuning fork, means frequency is changed. Okay, frequency is changed. For both case, what same? Or whether you make the level change or you change the tuning fork, what quantity always the same? The speed of the wave does not change.
Yep.
Okay. Any other question?
17.
17, 17. Okay. 17. Oh, okay, this one. Pressure. Diagram shows a flask connected to a U-tube containing a liquid. The flask is containing atmospheric pressure. The flask is now gently heated, and the liquid level in the right-hand side of the U-tube rises through a distance of 3 centimeter. So the right-hand side rises by 3 centimeter. What is the increase in pressure? I think there is one pass here. If this rise by 3 centimeter means it rise by